So if you remember the last time we had a discussion on what kind of property that the covalent bond has. And from that discussion, we actually get a very minute idea that what kind of characteristic and what kind of situation, in a different situation, the covalent may act differently. And it was also given an idea that how the covalent bond forms. So today we're going to talk about condition for the formation of the covalent bond. So first condition you are seeing over here is both atom must have 4 or more electron at the last shell. Just remind yourself about the things that we have learned in the definition of covalent bond. What we have learned there, the covalent bond basically was forming between the two electronegative elements. Now, when an element becomes electronegative, when their shell has the 4 or more than electron, 5, 6, 7, whatever, has 4 or more than electron, it becomes electronegative. And what was the electronegative? It was the tendency to gain the electron. So what was happening? A bond was forming between two elements or between the two atoms which has the electronegative property. That means both atoms must have 4 or more electrons in the last shell. Or we can say they must be non-metallic. Why? Because all non-metallic has 4 or more electrons in the last shell. So the covalent bond was forming between the two non-metallic elements or forming between the two electronegative elements. So this is clear why the first condition we need to have, the bond must be between when an element has 4 or more than 4 electrons. Now next you're seeing is it must have high electronegativity. This relation or this condition is actually related with the first one. Why? Because the high electronegativity comes when an atom has 4 or more electrons. So 4 or more electron it will be, then it will have a tendency not to lose the electron but to gain the electron. And the tendency to gain the electron is actually electronegativity. So if an atom having larger electron, 5, 6, 7, the more electron it will has at the last shell, the more electronegative it will be. The next one you're seeing this is high electron affinity. What is the tendency of high electron affinity? Just related with the second point or related with the first point. Electron affinity is the tendency that some atom wants to gain electron. Similarly, like electronegativity is there. Affinity means a kind of tendency to gain something. So same thing is there. If it is having high electronegativity, high electron affinity it will have. Means it will try to acquire electron to complete its shell. Just take an example. We have had a discussion a lot of time in this, that whenever an atom is having 4, 5, 6, 7, 8 is completed. We will not talk about the 8, 7 we are talking. Then atom will try to gain complete octet state. So if it is having 4, it will try to acquire 4 electrons. Means the electronegativity is decreased in this case. It is also less in this case, electroaffinity. But in the 5, it will be more. But in the 6, it will be more. But in the 7, it will be more. So what we are actually understanding from this is the more electronegativity will be there, the more electron affinity also will be there. And more electron affinity, it will have a more likely to form a covalent bond between the two atoms. High ionization potential. Basically, these terms might be reminding you about the first chapter in the periodic table that we have done in the classes. Okay, that's why I'm not uploading the video on it. Ionization potential was, what was that? It's the amount of energy is given. Suppose this is the hydrogen having an electron. The amount of energy is given to an atom, or the amount of energy is gained by electron in the last shell of an atom to emit from the last shell. So means if some element having a less ionization potential, what will happen? A little amount of energy we will give, electron will lose. But what happens with the electronegativity element or the non-metallic element? they have a very less tendency to lose electron. Very less. They have the more tendency to gain electron. So if they are having a gaining electron more, that means the ionization potential will be very high. So the same thing you need to remember, all the three things must be high: electronegativity, electron affinity, and ionization potential. Three things must be high in the case of formation of covalent bond. Now last one is electronegative difference is zero or almost zero. Why electronegative difference is zero? Suppose, just take an example of oxygen. What happens with the oxygen? It has a 6 electron in the last shell. Okay. So what is the oxygen is so much electronegative. But what is happening? The same strength oxygen, strengthable oxygen is coming in contact with the other oxygen. Now what will happen? Both wants to gain the electron. But what is happening over here? Both are equally powerful. So they decided not to gain or not to lose. They decided to share the electron. Share the electron. So you are getting this idea why we need to have electronegativity almost zero. Always remember, in the case electronegativity must be equal in the case of non-metal. If the metal have the electronegativity as well and has the electropositivity as well, but in the case of metal, electropositivity is more than electronegativity, and in case of non-metal, electronegativity is more than electropositivity. So always remember this. So we're just talking about the non-metallic condition. Okay. So electronegative difference has to be zero over here. Why? Because just take the example of hydrogen. Hydrogen is very weak electronegative non-metal. Okay. But what is happening? Suppose the hydrogen, just take an example from the physics. Actually, it not exists. Suppose the hydrogen can apply 2 Newton. And this hydrogen also can apply 2 Newton. There is no actually conceptual relation. Just for your sake of understanding, I'm giving an example. Okay. So suppose you're having a kind of man which can apply a 2 Newton, and this is hydrogen is a kind of man is also can apply 2 Newton. Okay. So that means what will happen? This hydrogen will try to gain the electron with the same force this hydrogen is trying. And this will form a covalent bond, a perfect covalent bond, or non-polar covalent bond. Covalent bond. NP-CP. Okay, that no need to remember this one. Okay, non-polar covalent bond. Just take an example, another example we are coming, taking nitrogen. Nitrogen, suppose. Nitrogen is having 5 electrons at the last shell. The same nitrogen, suppose the nitrogen can apply 5 Newton, and this also can apply 5 Newton. So what will happen? In this case, suppose the nitrogen is a kind of woman who can apply 5 Newton, much more than the hydrogen which was man. Okay, and this nitrogen was also can apply 5 Newton. So what will happen? Both of them are fighting to gain the electron. Then they both mutually decide, okay, let's not have or give, just do one thing, share. So this kind of non-polar covalent bond will form. But what will happen if hydrogen is reacting with the chlorine? Chlorine is very high electronegative and hydrogen is very low electronegative. So what will happen in this case? Electron will go close to chlorine, away from the hydrogen. But still it is a covalent bond because hydrogen is not completely losing or chlorine is not completely gaining. Okay, because they have both have the electronegative difference. So in the same case, suppose if you're just pulling somebody else, okay, so what will happen when you pull somebody else and comes to you completely? That means it applied zero force, but it is still not coming towards you, means he's applying or she's applying a certain kind of force that keeping them at a certain distance apart from you. So same things happen. It has the electronegativity. Chlorine has a much more higher electronegativity, but hydrogen is still electronegative and wants to gain the electron. Chlorine is more electronegative. It wants to have the electron, but it keeps the electron close to it. We had a lot of time in the discussion on this. Just what happens basically in the exam? The exam, they don't ask simply give the condition for the formation, and they don't ask for a long question. They only ask a very short type of question, one word question or just reason type question. So whatever you may be studying, you must be answerable of every thing that you are studying. There must be a reason that you're studying something, and that reason is basically in the form of concept. So concept you need to keep clear whenever you are reading a single line. You must be clear about what single line is actually specifying or signifying, basically. Okay, so this is the condition for the formation of bond and covalent bond, basically, and hope the idea is clear. And if you have any problem, do contact me. Thank you so much.